Hi there, welcome to my channel. In this video, we are going to solve another interview problem. And the question is to convert sorted array to binary search tree. And I hope you all are aware with binary search tree. In binary search tree, right elements are greater than the root node and left elements are smaller than root node. So we are given with the array, which is already in ascending order. So we just have to convert it to BST, which is we have to convert it to height balanced binary search tree. So we are given with the example where we have an array minus 10, 3, minus 3, 0, 5, and 9. And here is the output. So we have to create a binary search tree, something like this. So let's see how we are going to approach this problem. So here, if you notice, we are taking a middle element and we are putting it into node. After doing so, we'll have left subpart and right subpart. So from left subpart, we are taking a middle element again, and we are putting as a node on the left side. Similarly, on the right side, we'll take the middle element. So we just have a two element. So in this case, this will be considered as a middle, and we are putting it to the root node. So similar kind of thing we are repeatedly doing. So this operation is very much similar to binary search. So let's see how to implement this particular problem in our code. So I'm going to write a simple JavaScript program. I'll call it convert to BST. Let me increase the font size a bit. And we are given with a array. So here, first of all, we'll check if this array is null. In that case, we'll just return null. Otherwise, we'll write one inner function here. Let's call it convert BST. And in this case, we'll have nums with us, then we'll have left and right. So this is our inner function which we have just created. Let's first define this inner function, then I'll explain this what we are doing here. So first of all, this we are kind of writing a binary search logic here. So if you remember binary search algorithm, what we do, we have a left and right indexes, and based on that, we do searching. And there is a termination condition in binary search. If left is greater than right, in that case, we return from there. So similar kind of thing we are doing here. And we also calculate a mid value of the array that we are going to do with math.floor and left plus right. We are just finding a middle element divided by 2. So we have a mid element with us. So in our case, we have to construct a tree. So for tree, we'll have a node and we'll have left and right side. So for that, we'll first create a node, new node, and we'll have some constructor function to create node. Let's say it like this. So this tree node, this is nothing. This is another JavaScript function. I'll quickly define it here. So it's nothing. It's just a constructor function, which I hope will be given in your question. And here we'll have value left, right, and we'll just do this dot value equal to whatever value we are passing. If it is not there, we can set it to 0. Similarly, left will be whatever left we are passing. Otherwise, we can put some default value or we can leave it like this. Similarly, so I've just created a constructor function and we are using it here. So here we have created a node because we are constructing a tree. And for this node, we must have a left subchild and right subchild. And for that, we are going to create a left for it. And for that, we are going to convert this same function recursively. And we'll pass this nums array. And while passing left and right, what will happen? We are going to split this array into two using this mid value. So this is a similar logic of binary search. So the left will be left, but the right side will be mid minus 1. So same thing we'll do for the right side. We'll have nums, but the left side will be mid plus 1, and the right side will be right. And after doing so, for the current node, we are just going to return it. So this is done. The function definition is completed. Only thing is left is to call this function. So we'll just do return convert est with nums, and the left and right for the whole array will be 0, the starting index, and left will be the length of this array. So this is it. Now let's go through this program once. Let's run through this input example which is given to us. We have -10, -3, 0, 5, 9. So when it comes, from here we are calling it, we are passing the whole array with 0 and the left index and the rightmost index. So it will come inside. We are taking a mid of it. So mid is 0. We are creating a new node. So 0 we have here. Then on the left side, we are calling this function. On the right side, we are calling this function. So in this case, we are passing left. So here as a left, we have 0. So we are just calling BST again with 0 and mid -1. So in our case, it is 1. So similar kind of thing we are doing here. And this time it will be 3 to 4. So recursively, we'll keep it calling. And at the end, we'll get output like this. So this is a simple recursive program. Let's see the time complexity of this. So if you notice here, we are touching each node exactly 1 times. That's why the time complexity for this particular function will be order of n. But if you want a detailed explanation how we come to this conclusion, you can ping me in the comment section below. I'll see if I can explain in my next video. So right now what is happening in recursive function, basically, so I'll tell you in short how we calculate this order of complexity for recursive function. So first of all, we have to come with a recursive function. So in our case, we are calling this function, which is for this particular function, if I say it's t of n by 2. Similarly, for this one, it is t by n by 2. So if we combine this two, we'll get 2t n by 2. And we have some constant with us because we are doing some operation in between. So this is your recursive function. And if you solve this function, you'll get a time complexity of order of n. And to solve this recursive function, there are various approaches. Feel free to check it on Google. So that's all, guys. This is what I wanted to cover in this video. I hope this video was useful to you. If you find it useful, don't forget to like, share, and subscribe. And I'll see you in my next video. Thank you.